Hey everybody, back again for our astronomy unit, and this time we're going to be talking about comets, what they are, where they come from, and how they've changed our planet Earth over the course of many, many billions of years. First of all, what is a comet? Well, we call a comet a dirty snowball. The reason why we call it that is when we first sent actual probes to look at comets, Comet Wild 2 is one of the most famous ones we looked at, we were surprised at how dirty they were. You know, when people looked at comets with telescopes or even with the naked eye thousands of years ago, hundreds of years ago, we thought they were these pristine, beautiful balls of ice flying around our solar system. When we actually got close to them, we realized they're not that pristine. They're very, very dirty. The reason why is they're filled with stuff like carbon, almost like charcoal, and filled with silicated matter, like sand. So basically what comets are gases that have frozen over. So different gases, hydrogen, oxygen, methane, ethane. Some of these gases come together and they make water, but it's frozen water, so it's water ice. It's carbon dioxide ice, it's methane ice, it's ethane ice. The reason why? They're really, really far away from the sun. They're orbiting way past Pluto. So when they get close to the sun, these balls of ice, things begin to happen. Now, this ice is sort of like the outer layer, if you will. Inside is where we see different things like sand, silicated matter, and like carbon, almost like charcoal. That's what gives them the dirty hue. Now, they're far away, but they get close to the sun. When they get close to the sun, interesting things begin to happen. It's very, very easiest for us to jump to when ice gets close to something hot, it turns into a liquid. That's not the case in space. When you're in space, you can't have liquids. Liquids need a surface area to form. So out in space, everything goes from a gas to a solid, or from a solid to a gas. That's called sublimation. So when a comet gets near the sun, it begins to sublimate. And all of that gas starts to fly off the core of the comet. And it begins to grow a long tail. These tails can stretch from wherever they are near the sun. They're not going into the sun or that close to the sun, or else they would just completely disappear. They're fairly close to the sun, but they're far enough away, 50 million miles away, whatever it may be. But from that point, 50 million miles away from the sun, those tails can stretch all the way to Jupiter, which is a couple 100 million miles away, 800 million miles away from the sun. So these tails are huge and long. And that's when it becomes important to us. Not only is the gas trailing off the comet, pieces of this silicated matter is trailing off the comet. Some of the carbonaceous material is trailing off in the comet to form that tail. And because the Earth goes around the sun in a very prescribed manner, we'll go through this tail. And when we go through this tail, we get what we call meteor showers. These meteor showers can be seen, and we know exactly when they're going to happen. There are very famous meteor showers, the Leonids, the Perseids, the Orionids, the Aquinids. We know when they're going to happen each year. Now, it doesn't mean we're going to see them. It could happen during the day. We won't be able to see anything. But for the most part, if you're lucky and you're in a place that's really dark, you can see these meteor showers, depending on where you are on the Earth. It could be on the other side of the Earth. You know, it could be in the United States, but in the western part of the United States, not the middle part. So you got to have a little bit of luck. Hopefully there's no cloud cover or anything like that. And you can go out and sometimes you'll see 60, 70 meteors flashing by in a matter of minutes. The meteors that come from a comet are like grains of sand. So they don't fall to the ground afterwards. They're just shooting through. And then you see that burst of light because of that friction happening when it enters the atmosphere. Now, comets have done a lot to shape the Earth. A long time ago, billions of years ago, scientists theorized that the Earth was basically molten lava. It had a surface like that, nothing that we could stand on or whatever. They now think that comets actually slammed into that molten lava, and that's what helped create our atmosphere, and that's what helped give us water. So without comets, we don't really know if the planet Earth would have formed the way it should have formed to support life. Luckily it did. Now, comets are still out there, billions of them, in the Kuiper Belt and the Oort cloud. Some of them we know exactly when they're going to come by. One of the most famous comets in the world is Halley's Comet. Every 75, 76 years, it comes by, and you can see it. I was lucky enough to see it last time, 1986. I'm hopefully going to be around still in 2061 when it comes by again. There are other comets, though, that are so far away that we might not see them until every couple of thousand years. And that might be a very surprise thing when we do see it. Like all of a sudden we know it's going to happen because we can monitor it with our satellites and whatnot, but we might not see it again for thousands and thousands of years after that. So seeing a comet is actually sometimes a stroke of luck. And they're very, very cool things when they're in the sky. They're very, very neat looking. So if you ever have a chance, if you hear about a comet that's going to come by, you should go out at night, take a look, see if you can see it. Very, very neat stuff. So basically, that's what comets mean to us. Like I said, they're billions of miles away for the most part. And they're some of the first things that were formed when our solar system was being formed. Before our sun was here, there was another star that exploded and let everything out that created the sun, the planets, the comets, and everything else like that. The comet material, because it got so far away from a heat source, actually coalesced in these icy balls, collected silicated matter and carbonaceous matter, and that's why you have them now. Luckily, the sun formed quickly enough that it could capture these comets, and they go around the sun just like everything else. All right, so let's go ahead and take a small little break while I get everything ready, and we're going to go ahead and show you how to make a comet. First thing you're going to need is some Alka-Seltzer. I'm going to rip this open, and I'm going to pop it in the middle here. I'm going to go ahead and use 2 just to make it a little bit more dramatic, but for the most part, your kids should only use 1. But if you have enough extra, they can use 2. Okay, so we're going to put that right in the middle here. Okay? Kind of break it up. You'll see why it needs to be broken up in a moment. Now, I told you before, there's silicated matter inside of a comet. This silicated matter is like sand. So I'm going to go ahead and put some sand on there as well. Like I said, little grains of sand is what actually makes the meteors that we see. All right? We're also going to put some rice in there. And that's just to show a little bit of how the inside, the core of a comet, is a little bit more solid than we once thought. All right? There's a lot more stuff going on in there. That's also why we put a marble inside, just to keep it sort of all together and solid. Now we're going to go ahead and put some food coloring kind of all around it. And you'll see why we do that in a minute. That's so when we put it in the water and the Alka-Seltzer starts to effervesce, you can sort of see like the tail sort of forming outside of it. Okay? So this is all our stuff that we need for the comet's core. This aluminum sheet represents the ice, and what we're going to do now is we're going to sort of put it together, but you want to make sure that you have a little bit of holes inside of it so that it can go ahead and get water inside for when we want to show it sublimating. And this right here can be like your tail going around it, just so you get an idea of how it looks. All right? Okay, so when we submerge this inside, we're going to start to see some very interesting things happen. See the tail forming, guys? All that blue stuff coming out, how it spreads around. That's exactly what would happen in space. Except it would be much, much larger and longer. And it would continue for a long, long time, and it would not stop fizzing after just a few seconds. So also you need to know that comets don't last forever. After a while, the ice will also melt away, depending how many times it goes around the sun. And then from there, the solar wind will blow it apart. All the sand and the carbonaceous material will be blown apart.